Hello, I just wanted to give you some insights about the group that I'm meeting with for day one, along with some of the instructional decisions that I made with that group. You'll notice that I started with a number warm up with this group. And the reason for a number warm up is it allows for us to spiral back to concepts that we've already worked with in group. And it allows us to see if those skills are still at the level that we'd like them to be at. So for this warm up, I chose to go to addition, and the reason for that is because I haven't taught addition for a few weeks. I also haven't gone back and done that for a number warm up in a while. So that's why I decided to do an addition problem with them today. You'll notice that I've asked them to do this abstractly in the number warm up, and that's because we've worked through this concretely and pictorially in past groups when we were working in that addition concept. And the reason I've asked them to do this abstractly is because, yes, we've worked on that in the past, but also we want our mathematicians to be efficient. And concrete and pictorial is so important. And once we have that down, we want to be pushing them towards that abstract stage. We don't want to keep them in the concrete and pictorial stage if they're ready for that abstract understanding. And because this group is in the 201 to 2 range for computation, they're at that average level. So they're right on grade level. So, and we know the expectations for on grade level addition is that they can show us using the standard algorithm. So that's why I'm expecting that from them in this number warm up. You're also going to notice that I've checked in with these students as they're working, and I'm really questioning what they're doing as they work. And this is because I'm noticing, I'm having them notice what they're actually doing in the problem. And this is important because it's taking us back to that concrete and pictorial stage, and they're having to explain why this works in the abstract and standard algorithm representation for addition. So you'll notice that I asked them about how they're adding numbers together, and if they have a 9 and a 2 in the tens place, what that really means. And it means a 90 and a 20. And what it means when you carry a 1, that means we're really carrying a 10 or a 100. So I'm not only really assessing them on their addition skills, but I'm also assessing them based on their number sense, because we're talking about place value within those numbers. You'll also notice as we move into the actual teaching part of the day, the teaching point, that we're working with in division. And as we work with division, the reason that we've kind of gone that way with this group is because we have a good understanding of multiplication, we have a good understanding of addition and subtraction. So the next step or the next area of that NWA report is within division. So because we've kind of worked through those first indicators within NWA continuum, that's why I've made the decision to go to division with this group. You'll also notice that I have referenced the mini lesson with this group. And I want to address that because not always will I talk about the mini lesson with my small group, because it's not always appropriate to do that. It is appropriate to do that with your average group because they should be working right on that grade level standard that you had taught in the mini lesson. Now, with our struggling mathematicians and our high-flying mathematicians, it's not always appropriate to address that mini lesson because you might be working on a totally different skill within computation than was talked about during that mini lesson. So, I mean, with my struggling mathematicians right now, we're working within multiplication, but we've moved on whole group into division. So it wouldn't be appropriate for me to reference that mini lesson because we're still struggling in the multiplication part of the NWA continuum. With my high mathematicians, I probably wouldn't address that mini lesson either because we might be working on an abstract representation of division or a different skill within computation. So that's why you hear me address the mini lesson in this small group because they're right on grade level. And I mean, the importance for mini lesson is we need to expose all kids to that standard that they're expected to be able to do in fourth grade. And our small groups are where we really get to differentiate that instruction for our students. So moving forward, I decided to go into a kind of I do. I showed them how division was working in a problem and a strategy that we could use to solve a division problem. So I chose to use base 10 blocks because I want us to be working in this concrete representation stage until I feel that we're comfortable enough in understanding what's happening within division. You'll notice we really focused in on just using base 10 blocks. And the reason for that is because I want them to have a good foundational understanding, first of all, of what's happening within division. This is the very first day that I've worked within division with this group. So I want them to have a good foundation concretely of what's happening in division and what division really means. So as time moves on and they become more comfortable with division, I want them to be inventing new strategies on their own, using tools that they feel appropriate to attack a problem. But to start out, I think it's important for us to scaffold that learning and kind of focus in on a strategy that they can use that's common for everyone. And then as we get more comfortable with division, they can start to invent those strategies. So that's the thinking behind everyone using base 10 blocks for this day one lesson. As we were working through this, I also use lots of vocabulary with the students. I try to weave in as much mathematical language as possible in a group because I think it's important for kids to be able to begin talking precisely about mathematics. And it's important because we want kids to be able to communicate with each other as well as other mathematicians. And we want them to be talking in an accurate and precise way. And this is going to help us as we think about number talks. We're going to have great thinking and language happening during our number talk time because they're going to be using that language that really explains to me as the teacher what they are doing. And they're also conveying a good understanding to other mathematicians in the classroom as they explain out their thinking. So that's why our vocabulary is so important, and we need to be meshing that into our lessons as much as possible. As I think back to things that I might change, I might decide to maybe show a problem where they didn't have to decompose a 10 or a 100 for that division problem, just so that they can see that not every time they have a division problem, they have to decompose a 10 or a 100 to partition that number. I also might centralize some of the tools in the middle of the table because sometimes kids were getting up to get a material across the table. So if I would have left those in the middle of the table so everybody could grab, they wouldn't have had to get up in order to grab those tools.